Watch this for everything. You'll need to know about the acceleration practical in your physics paper 2. This required practical investigates Newton's second law. Remember, that has this equation, F equals ma, and it is the acceleration of an object is proportional to the force that causes it, in words. And this practical has 2 parts. We can test either how the mass affects the acceleration or how the force affects the acceleration. For both of these, the setup is very similar. You take a trolley, you put it on a ramp, you take some string, attach it to your trolley, put it over a pulley and put masses at the end. We then use light gates, which are like these little U-shaped things. You have a little card on your trolley, it passes through and triggers the light gates. We use those to measure acceleration. If you didn't have light gates and a data logger, you'd have to use a stopwatch and calculate it. Much more long-winded, just say use light gates. Now remember in the equation, F equals ma, if I wanted to test how force affects acceleration, then everything else that could affect the acceleration, I need to keep constant. So in this case, that would be the mass. We'd change the force like this by adding more and more masses to the end of that string. Those masses at the end of the pulley act as our force, pulling our trolley down that ramp. But people often forget, if we're changing force, we need to keep the mass constant. So whilst changing the force, adding or taking away masses from this pulley, we need to be transferring masses from that pulley to the trolley to make sure the mass of the whole system remains constant. If you didn't do that, you're changing 2 things at once. That's an unfair test. Your results would be invalid. If instead we're investigating how mass affects acceleration, all you need to do is simply add masses to your trolley to change the mass. No need to be transferring them from the pulley to the trolley in this case, because in this case we want the force to remain constant. So either always have the same masses at the end of the pulley, or just don't have anything pulling the trolley down at all. Just let it fall down the ramp. Then linking this to F equals ma, if you change the force on the pulley, you should see the acceleration will increase, a direct proportion relationship. And if you increase the mass on the trolley, you should see the acceleration will decrease. So that's the method summed up. You're changing either force or mass and seeing how it affects your acceleration, making sure you control the relevant things depending on what it is you're changing. Other than what I've already mentioned, pretty universal things to control would also be how you release the trolley each time, the height of the ramp itself, although I have seen questions where they're investigating how changing the height of the ramp affects acceleration as well, just so you know. The smoothness and the length of the ramp would be good to control too. Then on to your results. If we're investigating force, you'd want to plot a graph of acceleration against force. And you should see a nice direct proportion relationship, a nice diagonal line like this going through the origin. For changing mass, do acceleration against mass, and you should see an inverse proportion relationship, a nice downward curve. That's one of the practicals. I hope it comes up, and if it does, you're now going to smash it. Make sure you save this so you can watch it before your exam again for a quick refresh. Let me know if there's anything else you need help with. Best of luck on Monday.